So this example is looking at logarithmic function, and after the transformation, what kind of changes is going to happen to the original one. The question A is just asking to graph the y equals log of base 2x, and then you can create a table. If you understand the log, you should choose couple numbers and make your table easier. So 1 over 8 for x will end up getting -3 for y. So you can see you can choose a bunch of number involve negative, 0, and positive. Right? Of course, you can put another number like 8 to get a 3. So anyway, we just use these couple numbers. I think it's enough. And add a 9 here. So we graph this original function, right? And then we're looking at another function is transformed based on the original one. So you can tell the key difficulties that people have is they look at the log, they're not familiar with it, and they kind of get confused that the -1 is happened to the y or happen to x. Now be very careful. The 2x here is a power, right? So the log, if you look at the order of operation, if we have the x given a number, for example 2, and then 2 times 2 we get 4, and then the log to 4 should get 2, and then -1. So -1 is your last step. So that's why you have to think the -1 is not a part of the power. But if you put a bracket here, see, if you put a bracket here, that's a different story, and then you should do this 2 minus x and then subtract 1 and all together as a power. But now that's not the case here. Okay, so and then we can just see how the transformation is going to happen. So if you first identify the x is from x to 2x, and then we can just make the if there's any point it's called x, y on the original function, and then we should have a point x prime, y prime on the new function. And here we can just write a complete function here, y prime, right? So basically any point of x, y is going to transform to x prime, y prime. And then if we make the 2x prime equal to x, and then we can get the x prime equals x over 2. And then if this 2x prime become x right here, if this one changes to x, and then you can see this is going to change to y. So that's why we got a y prime equals to y minus 1. And if you isolate the y, you can tell it's you don't need to the y prime is already isolated, so we don't need to do anything. So we can tell right away that two transformation. One is horizontally, the original x divided by 2. It must be horizontal compression by a factor of 1 over 2. And then the vertical is a translation, 1 unit down. If you look at the transformation and then if you graph it, it's interesting is that you see we go through 2 steps. So this is our original graph. So if we have a horizontal compression, is likely to become something like this. So I just put the red one here. So that's actually is the function y equals log base 2x. So that's a horizontal compression by half, so we should get something like this. And then based on the red one, we have a vertical translation 1 unit down. So then if you go 1 unit down, so you can get back to this function which is exactly same as the original one. And if you're not convincing, we actually can look at its algebraic expression of this transformed function. So you can see log base 2x minus 1. We can change the 1 into a log to 2 that equals 1. And then we apply the quotient law to combine this 2 log into 1. So we're going to use the 2x, one of the power, divided by 2 another power. So we end up getting exactly same as the original function. So that's why it's actually, after the 2 transformation, it just transformed back to itself. Okay, although it doesn't look like the same, but you know, you can see here after the kind of manipulation, and you can actually get back to the original form. And since it's same as original form, and all the x-intercepts, asymptote, domain, and the range is just as same as the original function, you can tell right away the x-intercept is just 1, 0. That's the point. Asymptote y(x) equals 0. That's the y-axis. And domain, you can tell the x can never be negative or 0. Right, this is asymptote, so they would never touch the y-axis. And but the range came from negative infinity to positive infinity, so of course it belongs to the real number. Okay.